Good morning, everyone, and welcome to this online morning boost. My name is Emma Eriksson, and I'm the CEO of the startup company Atium. And today I will give you a short introduction to what we are working on at Atium.
Clean water is one of the greatest future challenges that the world stands before, and pollutants such as toxic heavy metals are a large contributing factor. We started Atium with the goal of helping combat global water pollution by creating innovative water treatment technologies. According to the World Health Organization, mercury is one of the most toxic chemicals to human health, and the problem with heavy metal pollution in water is widespread. Mercury can reach our bodies through our drinking water and the fish that we eat. Exposure to high levels of mercury causes severe damages to the central nervous system and the development of the brain, often leading to mental disabilities. This makes it especially harmful to young and unborn children. To prevent mercury from reaching our nature, movements such as the Minamata Convention on Mercury are pushing for action, and strict regulations are being implemented to force industries all over the world to clean their waste and their processed water. Cleaning of heavy metals are often both time-consuming and very expensive, and we have seen that there is a clear demand for cheaper and better water treatment solutions. At Atium, we are developing a new method based on electrochemical alloy formation for effective removal of mercury. And by applying a potential or electricity, we can bind the mercury atoms, which you can see here as purple in the figure. We bind the mercury to the electrode material. The electrode material here is the gray part. And we form a strong and stable alloy, as you can see in the last picture here. Here, the electrode material is platinum, which is very suitable for removing mercury, as each platinum atom can bind 4 mercury atoms. And this process is reversible. So this is the core of our technology, and I'm now going to show you a more illustrative picture of how the technology actually works. So a water stream with mercury enters the filter. The mercury is captured in the electrode. This can be done without the need of any extra chemicals. When the electrodes are saturated with mercury, they can easily be replaced with a new set of electrodes. Then the saturated electrodes can be recycled and the mercury is safely disposed of. And thereafter, the process can start over. So compared to existing technologies, our method has 3 main advantages. It is effective at removing low concentrations of mercury, which are normally both difficult and expensive to target. It is selective, meaning it does not waste capacity on harmless substances. And it is more sustainable, since it's reusable, it's energy efficient, and it reduces the amount of secondary waste being produced. So with these strengths in mind, we see an opportunity to use the technology for selective purification of low concentrations of mercury in large quantities of water, which is a major challenge today. Above all, we can create value as a final step in the water purification process to ensure the quality of the water that is released from the industry. Combining this with the ability to automate the regeneration process provides 3 benefits to the customer. Lower emissions to meet current and future legal requirements, lower operating costs, by removing both manual maintenance and consumables, and enabling circular models where both the water itself and the mercury can be reused if needed. And these strengths have resulted in large interest in the technology from several different industries, especially treatment of industrial wastewater. For example, Innovin, a chemical factory placed in Stenungsund, within dental clinic wastewaters, and treatment of acids. And then we mostly talk about acids from smelters. And this is our first prototype for dental clinics, a market with significant mercury emissions, where we are discussing a partnership together with Sweden's largest supplier of current solutions to quickly launch a product on this market. Today, every dental clinic must have a so-called amalgam separator to remove the mercury from the water. Most of the mercury comes from old amalgam fillings, which consist of more than 50% of mercury. However, these separators only target the particles, and as mercury is very soluble in water, a lot of mercury passes through these. Mercury from dental clinic is actually the largest source of mercury that comes to our water treatment plants. So this is a niche market, but with a great demand for a better solution. And this is our team at Atium. Johan, Björn, and I co-founded Atium through Chalmers School of Entrepreneurship about 2 years ago. Björn is a researcher at the Department of Physics at Chalmers. I have a background in biotechnology, and Johan has a background in business and marketing. And Jan is our advisor and chairman of the board. Then we have another Emma working in the lab, mainly with the lab analysis and lab experiments, and Alexander working with product development. And so far, we have financed the company and the technology development entirely through soft funds. During the past year, we have withdrawn approximately 2.5 million Swedish crowns for the project from a number of different actors, such as Venture Cap, Energimyndigheten, and Vinnova. But we are now in the process of closing our first investment round, this to accelerate the development of the technology. We are currently in Chalmers Ventures Scale program, and we have also been taking part of EIT Raw Materials Accelerator program. And this is roughly where we are today. We filed a patent application for the technology in late 2017, and we have verified the technology in the lab through several different lab tests, both with synthetic water and also water from different industries. And we are now preparing for pilot projects to develop and test our prototypes in a real setting. And the goal is to find an early adopter and then scale from there. And we focus on industrial applications due to the large demand that we have seen there, but there is also future potential in drinking water treatment and the development of a sensor. And by offering a more effective and sustainable water treatment solution, we hope to contribute to a world where clean water is available to everyone. And that was it from me today. And if you have any questions, feel free to ask anything, either if it's about the technology or the company or anything else. Thank you for listening.